asteroid strikes the ground, it buries itself in the Earth in a period of only 1 second. It opens a crater, a hemispherical hole in the ground that reaches a diameter of 30 miles about 10 seconds after the impact occurs. That time it's 15 miles deep. It's lined with red-hot rock debris streaming outward, forming a plume heading into the sky. At that time, the crater floor begins to rise back up. At the same time, the diameter of the crater continues to increase. It goes on until it reaches a diameter of about 100 miles before it stops growing. What happens next is really interesting. As the asteroid plunges into the ground, it creates pressures about equal to that of the Earth's core. Under those pressures, the asteroid and also some of the Earth rock melt and vaporize and expand back out of the crater as a plume or glowing cloud of very high velocity gas and dust. This cloud expands at velocities up to the Earth's escape velocity, sending the debris into ballistic orbits that eventually rain back all over the Earth. Trillions of tiny particles of this kind would fill the sky, radiating heat toward the ground. On the ground, you would feel an effect very similar to that of an oven on broil, lasting for about an hour. Even green vegetation would dry out and begin to burst into flames spontaneously as a result of this thermal irradiation, causing global forest fires.
There is evidence that this actually happened. Millions of microscopic carbon spheres have been found in the clay that was deposited at the end of the Cretaceous period. Soot from some enormous conflagration. And this clay layer has more surprises in store.
Gee, that's pretty neat. Yeah. It's right in the impact layer, yeah. Great.
At the United States Geological Survey in Denver, Glenn Isett and his colleague Fred Littker use a laser to analyze rocks from the Cretaceous tertiary boundary. The laser vaporizes the sample of the clay layer with pinpoint accuracy.
Here comes the Cretaceous sample. We'll load the last sample we did, the impact layer.
So the white spectra here is the Cretaceous marl.
That's right.
And that's superposed with the blue spectra here, which is the overlying impact layer. So where's the iridium, Fred?
Okay, the iridium. Let me show you here.
Iridium, rare on Earth but common in asteroids, is shot through the rock. In this sample from Colorado, the iridium is represented by the highest blue peak. And it's typical of hundreds of others found around the world.
So we have two isotopes approximately in the right order for their natural abundance.
Isett finds that the clay also contains unusual and, he claims, significant grains of quartz. Viewed in polarized light, quartz usually appears featureless. This is the quartz from the boundary layer.
It shows these very peculiar lines through the quartz grain. They're oriented in this particular grain in this direction and this direction. These are called shock lamellae, and the only place that these have been found in rocks of the Earth's crust happen to be at high-yield nuclear explosion sites or at known meteor impact sites.
Iridium, soot, shocked quartz. All these pieces of evidence do point to an asteroid impact at the end of the Cretaceous. But if an asteroid hit the Earth, where is the crater? It would have to be of an order of magnitude many times larger than the crater in Arizona. Glenn Penfield is a petroleum exploration geophysicist. In 1978, he was working in the Yucatan in Mexico.
Muy buenos días, Capitán Bolio.
Buenos días,
Glenn
ingeniero. Buenos
Penfield.
días.
Quiero contratar.
He was trying to find underground oil deposits for Pemex, the Mexican National Oil Company. In a series of aerial surveys, he measured faint variations in the Earth's magnetic fields. With luck, these would reveal oil-bearing structures beneath the surface. The work was straightforward enough, but as the survey progressed, something unexpected began to emerge.
From the beginning, when we first collected data from the aircraft, I began noticing a pattern of extraordinary symmetry in the magnetic anomalies. Later, we put these into a map, and the picture held up, one of a zone of highly magnetic material, an enormous ring of very intense magnetic anomalies that you can see here on the map, about 70 kilometers across, with very, very strong gradients in the field. Further out, a ring of very subtle features with a diameter of about 210 kilometers. A similar sort of configuration of anomalies is visible in the gravitational data. We see a central ring of high gravity anomalies indicating more dense material here in the center, again about 65 kilometers across, then a gravity low indicating lower density material, and finally another gravity high 180 kilometers in diameter. This area had been interpreted as containing volcanic features, but I had never seen volcanic features with this kind of symmetry on this sort of scale before. And it appeared to me that this had to be the result of a single event that at one time froze both the gravity and the magnetic fields in this highly symmetrical, highly ordered arrangement. And the most likely explanation to me was that of a gigantic meteor impact.
Nature's killing machine against the only man prepared to take the risk. The real Crocodile Dundee, tomorrow from 8, only on Discovery Channel.
Hiya! Come and see what we've got in the B&Q sale.
We've got big savings on Dulux Emulsion.
Look, 72 towels for only £6.
Save pounds on this Ryobi hobby tool.
Lots of our kitchens are reduced. This one's a third off.
There's £60 off this bathroom suite, including the taps.
This powerful Karcher pressure washer is now only £119.
Look, a cordless alarm system, and now for under £80.
And that's just the beginning. The B&Q sale starts Boxing Day.
Screen Shop presents the Country Collection. Now you can buy one of the best ever country music box sets with some of the most famous names in country music. Hear Boxcar Willie, the king of the road, with 20 classic tracks. 20 of the best songs from George Jones. The legendary Willie Nelson with 20 country greats. And the man in black himself, Johnny Cash, singing 22 of his greatest hits.
Always be a good boy, don't ever play with guns.
Live in concert, Merle Haggard.
From Muskogee, yeah.
Gentleman Jim Reeves with 18 very special love songs.
Am I losing you? Oh, the crystal chandeliers on
Charlie Pride in concert with 20 of his finest. And Kenny Rogers' country collection with 18 great songs.
Don't take your love to town.
8 fabulous picture CDs, over 160 songs in a beautiful presentation box. Will also include 2 extra discs featuring Patsy Cline and Tammy Wynette live in concert, all for only £29.95. The Country Collection, brought to you by Screen Shop. Pick up your phone and order now.
This is an NSPCC Christmas appeal to ask if you can give £15 now to help save a child's life.
So, let's find out what everyone got up to at Christmas. Rachel.
I saw Father Christmas in his magic grotto.
Gary.
We had Nanny and Grandad over.
What did you do at Christmas, Karen? Karen?
Oh, for goodness sake, why do you have to be so dramatic?
Stop with them, but the problem is I just want to go to bed. What
If you could just try
For abused children like Karen, Christmas isn't a time of loving and giving, but just another day of terror and pain. Between Christmas and New Year alone, we estimate one child under 5 dies following neglect or abuse.
Karen? Karen?
Nothing, miss.
You can help. Call 0800 597 5000 now. Just £15 will help us counsel abused children and work with families. And it'll help us to continue to be there for a child at risk, a child like Karen. So this Christmas, please imagine there's an extra child to buy a gift for, and call the NSPCC on 0800 597 5000 to give £15 or whatever you can. That's 0800 597 5000. We're waiting for your call now. Thank you.
Discover the ways of the natural world with the fiercest, fastest and largest animals alive. Enjoy a wildlife adventure that spans the most remote places on Earth. Get closer to the animal kingdom in Wild Discovery tomorrow at 6 on Discovery Channel.
This is the Brazos River in Texas. In 1987, Alan Hildebrand, then a PhD student at the University of Arizona, Tucson, had heard about the Alvarez impact theory and was conducting his own search for a likely crater. At the time, he had never heard of Glen Penfield.
Today, the Brazos River here is about 200 miles from the Gulf Coast. 65 million years ago, the late Cretaceous sea covered this area. Here it was about 500 feet deep. Along the banks of this river, we see the fossils of ammonites and other marine creatures that lived along with the dinosaurs and went extinct along with the dinosaurs at the end of the Cretaceous.
Hildebrand knew that hidden in the riverbanks is one of the world's most unusual Cretaceous-Tertiary boundary sites. In most places, the Cretaceous and Tertiary rocks are separated by a very narrow clay layer, one that is no more than half an inch thick. But on the bank of this river, there is a rubble-filled interval almost 3 feet deep. Here, the dividing line between the world of the dinosaurs and the world that came after is startlingly clear.
This outcrop shows the Cretaceous-Tertiary boundary section. My feet are resting on the Cretaceous sediments. This is mud that was deposited in a sea that was about 500 feet deep. Here's the base of the Tertiary. From here upwards, we have sediments that represent a time when the dinosaurs were extinct. There's about 3 feet of sediment in between that indicates something extraordinary happened here. In particular, this lump of gray clay, which is a bit indistinct. See, it goes around like so. This is a boulder about 3 feet across. Something happened that was able to uproot this gray clay from the Cretaceous seafloor and transport it and dump it here. Similar deposits of rubble like this occur all along the southern coast of North America at the Cretaceous-Tertiary boundary. The presence of the rubble beds here and the rubble beds all along the southern coast of North America indicates that something extraordinary happened here, something like a giant wave washing across the southern margin of the continent. We can't imagine how such a giant wave could have formed except for something like an impact in the ocean.
Still unaware of Penfield's work in the Yucatan, Hildebrand first suspected that a circular feature on the ocean floor off the coast of Colombia might be the crater. He was looking for the bruise left on the face of the Earth by a meteorite blow. Then he heard about another site, this one in Haiti. "65 million years ago, this region, like that around the Brazos River, was beneath the sea. High in the mountains, near the village of Belloc in Haiti's southern peninsula, there was a curious sequence of marine rock. It was discovered by Florentine Moras, a native-born Haitian, now at Florida International University in Miami.
This is my site. That's the Belloc Formation. The bottom two-thirds from the valley is Cretaceous, and above it, that's Tertiary. Right about one-third from the road, you can see a little quarry, and that's where we have the KT boundary.
The KT boundary is what scientists call the layer of rock laid down at the end of the Cretaceous period. At first, Moras thought he had found the traces of an ancient volcano. Not until 15 years later did Alan Hildebrand suggest that, like the Brazos River site, it might indicate the presence of a nearby impact crater.
Okay, this is another piece of the boundary layer. As you can see here, it is very, very distinct. At the bottom, that's Cretaceous, and here that's the boundary, the so-called boundary layer. And we are going to take a sample to show you what it looks like.
It was at this point in September 1990 that the filming of this series itself played a small part in the story. Samples collected for our purposes proved to be of particular interest for both Florentine Moras and geologist Glenn Isett.
Here's a sample of the rock that you see here being collected by Florentine Moras and that the dinosaur production team was kind enough to bring back from Haiti. I've mounted the rock sample in plastic and then ground it flat so we can see what's going on with this in this rock. What really drew my attention is this zone here in the base of the sample, about 2 centimeters thick, of greenish black pellets.
Seen under the microscope, the pellets had a curious and distinctive shape. They resembled tektites, droplets of molten material splashed out of the earth by an impact and then frozen into form. A drop of milk falling into a bowl creates the same forms as it splashes into the liquid beneath. Tektites in the boundary layer would prove that an asteroid impact occurred at the end of the Cretaceous period. Isett took a closer look at the interior of the molten pellets.
It turns out to be a black glass, real tektite glass. It demonstrates that there really was an impact at the Cretaceous-Tertiary boundary. Tektites have only been found associated with large asteroid or comet impacts.
Meanwhile, Alan Hildebrand was still scouring the scientific literature, looking for word on circular features that would prove an impact once occurred. Finally, he came across Penfield's article on the Yucatan crater. In it, Penfield mentioned the lost samples of rock. But where were they? Hildebrand persisted in his research.
I wrote people, I called people, I talked to dozens of different people, and finally, with the help of colleagues, we got lucky, and I found that a set of samples have been sitting in New Orleans for the last 20 years.
In April 1990, Hildebrand passed the information along to Glenn Penfield, and Penfield paid a visit to the geology department at the University of New Orleans. After 12 years, his quest was almost over.
This is typical of the limestone rock present in the Yucatan No. 2 well.
The well that had been dug in Chicxulub. There were scores of samples produced as the drill chewed its way through 10,000 feet of the Earth's crust. They looked very much alike, except for one.
This one here, from 301 to 303 meters, is unlike any of the others. Green, full of fragmented shards of broken up rocks that existed previously. It has a texture totally unlike any of the other samples of the limestone throughout the well. And it signifies a rock put together of fragments of pre-existing rock, disordered and jumbled together and broken up.
Penfield sent a sample to Alan Hildebrand to look for the key features that would signify the impact of a comet or asteroid, iridium, or shocked quartz.
When Glenn Penfield sent me the first samples we'd found in New Orleans, we did a couple of separations of them, and we found some shocked quartz in both of the samples. And of course, with the duplication and the care we take in making these preparations, we were quite sure that we'd established that shocked quartz occurred in this deposit outside but near the crater. So likely the big hole nearby was a crater.
Millions of years ago, something happened here. A gigantic explosion that sent shock waves hundreds of miles in every direction, carrying debris at least as far as the coast of Texas.
We're sitting here at ground zero in the Chicxulub crater. It stretches for 90 kilometers in every direction around us and represents one of the most cataclysmatic events in the Earth's history. We named it Chicxulub, both for the village nearby here and for the first well that was drilled into the structure, but also appropriately because Chicxulub in the ancient Mayan dialect means the tail of the devil.
The Yucatan crater is in the right place and it's the right size. But is it the right answer? Perhaps the dinosaurs were already becoming extinct. Scientists know that 61 kinds of dinosaurs were alive 6 million years before the end of the Cretaceous. But 2 million years before the end of the Cretaceous, there were only 18. Recently, new evidence has come to light that something did indeed hit the Earth in the late Cretaceous period. But most paleontologists are reluctant to accept the idea that this event could have extinguished the dinosaurs.
Okay, the asteroid theory. Does it explain the extinction of dinosaurs? There are problems. There is the frog problem. You see, there are thousands of species of tropical frog today, and frogs are immortal as family of species. They never suffer mass extinction. When the mammoths went extinct, the frogs survived. When the dinosaurs went extinct, the frogs survived. And frogs are very delicate animals, very delicate to climate change. If you smacked the Earth today with an asteroid, blotted out the sun, you would freeze frogs long before you'd freeze a big animal. What kills off big animals like dinosaurs or elephants? What does an elephant do that a frog doesn't? Elephants spread.
Dr. Barker points out that large land animals, such as elephants, travel enormous distances in the course of their lives. In this sense, dinosaurs resemble today's fast-moving beasts capable of traversing large expanses of terrain. And towards the end of the Cretaceous period, dinosaurs do seem to have gone traveling in large numbers. Newly formed land bridges connected previously isolated continents and made it possible for dinosaurs, if they wished, to walk from Mongolia to Montana. This brought different species of dinosaur into contact with one another for the first time. which leads to the theory of dinosaur extinction favored by Dr. Barker. Barker points out that in the late 19th century, the disease rinderpest spread from Asia to Africa, threatening the extinction of nearly 40 species of African antelope. In the same way, he argues, when dinosaurs crossed the land bridges, they were exposed to new strains of disease that could have wreaked havoc among dinosaur populations. Like the colonists who brought measles to the Americas, when dinosaurs spread, they spread disease and became, in turn, the victims of their own relentless exploration. What caused the dinosaurs to vanish from the Earth? No one knows for sure. There is no agreement on a most likely answer. But what we do know, as a result of the surge in dinosaur studies over the last 40 years, is that the old picture of dinosaurs was wrong. These were not sluggish, small-brained blimps. They were gloriously varied creatures, some striding boldly along on 4 legs, others skimming the ground on 2. Some were hot-blooded, many were gregarious and social. They traveled far and wide, armed and ready to do battle for food, or to die in defense of their young. Tyrannosaurus rex, Iguanodon, Brontosaurus, Deinonychus. Though long dead and buried, they still roam free in the forests of our imaginations, and more of their kind wait still, frozen in stone, to enthrall those who come after us, children and scientists alike.
So the dinosaurs went extinct. Things like Allosaurus and all its giant kin died out. Is that a tragedy for everybody? Well, no. If you were small, you survived. And if you were small and furry and had a twitchy nose and beady eyes like this chap, you could evolve into a wonderful range of big mammal families. You could evolve into moose, you could evolve into aardvarks, into warthogs, into apes, into humans. So from an ancestor like this came people. Humankind owes its success story to the extinction of giant dinosaurs.